Hello, everyone, and you are welcome to the fourth session under Unit 2. And in this session, you are going to look at carboxylic compounds. So, at the end of the session, you should be able to use qualitative tests to identify carboxylic acid compounds. So, briefly, we can look at what carboxylic acid compounds are. They're the compounds bearing the, the COOH functional group, right? So, there's no actually a single test to test for carboxylic acid. However, they can be confirmed with series of tests to show that yes, this um, unknown compound contains the carboxylic acid functional group, right? So you have the reaction with water. Carboxylic acids are weak acids, right? So as such, they are only partially ionized in aqueous solution, and most are reasonably soluble, giving a pH with solution with a pH in the range of 3 to 5, right? And then the long chain carboxylic acids only give a marginal change in the pH. I mean, that's slightly different from this. Other than that, they mostly have the pH range around 3 to 5. Now, in the test for carboxylic acids, they can be um, confirmed with the phosphorus pentachloride reagents. So carboxylic acids contain the OH group, right? The OH group. So they therefore react with the phosphorus pentachloride in the same manner as described for alcohols. And then also there's also the sodium carbonate or the sodium hydrogen carbonate test. So carboxylic acids are weak acids, right? But generally they are acidic enough to react with both sodium carbonate and sodium hydrogen carbonate to produce carbon dioxide. Right? So by adding 1 ml of your unknown and then adding 1 ml of sodium carbonate solution or sodium hydrogen carbonate solution, the okay, so the positive end result is the formation of the effervescence. Now this effervescence can be collected into a disposable pipette and then bubble through 1 ml of lime water. So if you bubble this through lime water and it turns cloudy, confirms the presence of carbon dioxide, right? So the reaction of um, your carboxylic acid functional group with the sodium carbonate or sodium hydrogen carbonate will lead to the formation of your sodium carboxylic acid derivative plus the carbon dioxide, and this carbon dioxide is a byproduct. So in the presence of the carbon dioxide, using the lime water to confirm its presence tells us that now our unknown compound was acidic. So this is distinguished from the now this distinguishes the carboxylic acid from weak acids such as phenols, which do not react with sodium carbonate at all. So sodium carbonate reacts with carboxylic acids. However, it does not react with weak alcohols, such as phenols. So this test, although may not necessarily tell us that our it's not an outright test for the presence of carboxylic acid functional group. However, it's a confirmation test because by confirming that there's the formation of carbon dioxide tells us that yeah, the compound is acidic and it's possibly a carboxylic acid functional group. Okay, so the next test we can look at is the esterification reaction involving our carboxylic acid with an alcohol. So if we have our unknown, we add about 1 ml of it to a test tube and then add our alcohol, in this case an ethanol. So if we add 1 ml of ethanol to 1 ml of our unknown into a test tube and then we add our catalyst, which is an acid, sulfuric acid, and then we heat this in the water bath for 5 minutes at 50 degrees Celsius. Now the product we are going to have has a peculiar smell. So after heating this and then adding our sodium solution will produce this glue smell. And then this glue smell is an indication that an ester has been formed, and this ester can only be formed if our unknown is what an carboxylic acid compound. So if our unknown contains the carboxylic acid functional group, then reacting it with an alcohol in the presence of a catalyst and then sodium carbonate will give us the ester product.